So if I'm sketching y equals the log base 1/2 of x, remember what that means is that x is equal to 1/2 to the y. And so when I asked for the points whose y values were -1, 0, and 1, I was giving you those exponents. Okay. All right, 1/2 to the -1 is just 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2. So if I plot those points, there's my 2, -1. There's my 1, 0. That's always going to be my x-intercept. And then 1/2, 1 would be right here. Now, I could have gotten that general shape by just saying, I know this was exponential decay. 1/2 to the x would have been exponential decay. If I turn and flip, I get something that looks like this. Those 3 points just have me draw things a little bit better to the appropriate scale. All right, so now in evaluating this transformation, what would I do in evaluating the function, and how does that transform the graph? Well, we always start with parentheses. So the first thing I would do is I would add 2. Once I have x plus 2, I'm going to take the log. And that's my parent function. Once I've evaluated the log, then I'm going to subtract 1. So whatever I do after the parent, that's a vertical transformation. Before the parent, that's a horizontal transformation. The horizontal are counterintuitive, so adding 2 actually moves things 2 to the left. Vertical, subtracting 1, does actually move things in the negative direction, so that's going to move things down 1. Okay. If you want to do them both in one step, I'm okay with that. I kind of like to be really systematic and just do everything one at a time, so that in one step I'm changing my x values and the y values stay put. And in the next step I'm changing my y values and the x values stay put. Okay, so from here, let's just come this way. Okay, I'm going to move things to the left too. So that's changing my x values. So this point was at 1/2. Subtracting 2, I'm subtracting 4 halves. So we're going to be at -3 halves, 1. And -3 halves is -1.5. So it's between -1 and -2. Subtracting 2 from 1, I'm going to get an x value of -1. Y value stays the same at 0. 2, -1. Subtract 2 from that x value, I'm going to be at 0, -1. Now, pretty obviously, the asymptote needs to have shifted because the asymptote was the y-axis, and now I'm both on it and to the left. So let's see. If we move things 2 to the left, the asymptote was at x equals 0. Now it's going to be at x equals -2. So I'll draw that in as a dotted line, and then I can connect these dots, and I know that this is the shape I'm supposed to have. Very, very steep as we approach that asymptote, getting much less steep as we curve down and to the right. Okay, so now I want to move things down 1. So I'll just come this way, moving things down 1. Please, as you're doing things, in this case, I've just got this board that I've got to recycle. Please try to make your work clear and easy to follow. If you do end up with something where you're here and then you're going in a weird order, just make it really clear. Like pick a different color and write start here. And then here we can say that's going to be my final answer. Okay? I don't expect your work to be absolutely brilliantly neat, but I do expect it to be readable. Okay. So ideally you would start in the upper left hand corner of the page and just work right and down. Okay. All right, so let's see. We're now subtracting 1 from our y values. So this point was -3 halves 1. That's going to now be -3 halves 0. Okay. This point was -1, 0. That's now -1, -1. This point was 0, -1. That's going to move down to 0, -2. Did our asymptote move? We have this vertical line. If we move it down 1, it's still in the same place. Remember, it was infinitely tall. So the asymptote is still at x equals -2. And now I can connect those points. Excellent. So there's our graph. If I look at my domain, just from the graph, it looks like it's everything to the right of -2. So that would be -2 to infinity. Now, if I look at the formula, which I've erased, but this was y equals the log base 1/2 of x plus 2 minus 1. So the argument of log, the thing we were plugging into log, was x plus 2. That has to be positive. That does become x is bigger than -2. So I can see the connection between the algebra here and the graph here. The range didn't change. That's everything from -infinity to infinity. And the asymptote, we said that was at -2. Just need to remember that with a vertical line, that means that x is fixed at that value. So our asymptote would be x equals -2.